Yeah, okay. I think we are live. Okay, so uh, let's get started. So hello everyone, I am Muhammad Sajeer. I'm doing my those who are new to this channel. I'm Muhammad Sajeer. I'm doing my PhD at IISc Bangalore. So this, as you are aware, 2022 CSIR notification is out, and they are saying it will happen in January or sometime that time. So we had to prepare accordingly. So these lectures I will be I'll do the revision. I'm not going to teach you from each point step by step in the basic. I'll do a revision, a general revision, so that you will be equipped with all the necessary things that will be helpful for your CSR net exam, coming CSR net exam. So this video is about solid state physics. This is lecture one, and we may have 3 or 4 lecture or around 5 lecture more, which will cover all the solid state basics, and we will also look into different questions asked in various other exams and all. So this will be enough for you to, I mean, not, I'm not saying it is enough, it will be helpful for you for this SR net exam. So let's get started. So basically in solid state physics, actually solid state physics part are mostly easy ones. So these ones you can easily score. There will be some questions in 5 marks C part and B part also. So there are some basic questions, basic things you have to know, so that you can directly just you can go. You don't need to spend a lot of time in solid state physics questions. Okay, so the basic things we all know is a unit cell. Unit cell, you know that it's a basic unit, or it is the smallest volume we can say, smallest repeating volume, so that the crystal can be made. That's a unit cell, and uh, and there are type of unit cell called as Wigner sets unit cell. In that, what we do is to draw a Wigner set unit cell. If we have a crystal at this points, we will draw connecting lights and perpendicular to it, and after that we will join and we will draw the Wigner sets unit cell. It's good, you will understand how they draw and all. That is not that much important. And in solid state physics, one of the basic equation is the density equal to Mn by Na a cube. Here m is mass, and n is that Avogadro number, that 6.0 10 raised to 23, and n is the number of atom per unit cell. So if you know Mn by Na cube, you can calculate the density. This was asked in GATE 2006. Maybe in recent ones also, but I am just mentioning the what they asked. So that's a basic thing. And we know there are Bravis lattices in solid state, right? Crystals are divided into different Bravis lattices. There are 2D, 3D Bravis lattices. In 2D, there are basically 5 Bravis lattices. Five Bravis lattices are possible in 2D, which was asked in just 2016. Okay. And there are examples: square is a rectangle, rhombus, parallelogram, hexagonal, that kind of shapes are there. And in 3D, if you look in 3D, there are 14 type lattices are possible. Brace lattices are possible in 3D. Okay, in 3D is possible, and in that 14 there is the triclinic, which is actually comes under general, and another 13 special ones. 13 are special. Okay. So this 14 is actually divided into 7 crystal groups. We are divided into 7 crystal groups. Okay, that we know, right? Uh, what I was used to remember, these things are like these 7 crystal groups are, I will number it. One is cubic. Second one is tetragonal. I'll tell you how we will remember all these things. Okay. Then we will have orthorhombic. Then we'll have a monoclinic. Then fifth one is hexagonal. Sixth one is robohedral. I'm sure most of you have studied even in your +2 these things, right? Triclinic. Okay. I was just remembering in such a way that CTOMH rotary. I don't know how we'll we'll find this CTOMH rotary. That was the code I was using. C for cubic, T for tetragonal, O for orthorhombic, M for monoclinic, H for hexagonal, Rho for rhombohedral, and Tri for triclinic. And also, for example, this rhombohedral is also known as, I guess it is trigonal. Okay. So how will you remember this? Okay. So the most basic thing is in okay. So most basic thing is in triclinic, everything is not equal to, okay. A not equal to, B not equal to C, and alpha not equal to, beta not equal to, gamma not equal to 90. That's the basic triclinic thing, okay. And all other ones are go like this. For example, the orthorhomb, for example, we'll go like this. See, cubic and rhobohedral, A, B, C laws are same. That is A equal to B equal to C. And another thing is like for cubic, it is alpha equal to beta equal to gamma equal to 90. For rhombohedral, it is alpha equal to beta equal to gamma less than 120 degree. Okay, 120 degree. Okay. Then the tetragonal and which one? Tetragonal and the top one. So tetragonal and hexagonal are around same. For tetragonal and hexagonal, A equal to B not equal to C, and then the alpha beta gamma, you remember, alpha equal to beta equal to gamma equal to 90. And for hexagonal, it is alpha equal to beta equal to 90 and gamma equal to 120. Equal to beta equal to 90, gamma equal to 120. Okay. Then we have this orthorhombic and monoclinic. For that, we have A not equal to B not equal to C. For an alpha beta gamma, in orthorhombic it is alpha equal to beta equal to gamma equal to 90, and for monoclinic it is yeah, correct. So monoclinic it is alpha equal to gamma equal to 90 not equal to 120. Alpha equal to gamma equal to 90 not equal to beta. Okay. So now right? For example, this is order CTOMH rotary, and from that I will just change the color. Okay. This is the order CTOMH rotary, and this order we can remember. Or another way is like, for example, if you see the first three ones, that A equal to, for first one A equal to B equal to C, and the second one A not A one this equal sign here, right? So this will go, and the third one and that all will go. See, all the equal signs will be not equal to. So and alpha beta gamma you can remember accordingly, right? So these are the basic crystal these structures. Okay. Now one thing is like we have to remember is this triclinic, right? Triclinic don't have a mirror plane. Think it was asked in one of the old ones, I guess. It don't have a mirror plane, or it can be asked. Okay, I don't have a mirror plane, and we know, and also and for so other thing is for a crystal we have symbol cube SC, we have body centered cubic BCC, and we have FCC, right? The volume ratio of symbol curve VS BCC VS VFCC is actually 1:2:4. Okay, and this ones we have to remember. For example, volume, we have symbol Q, we have a cube, we also have a cube, we have a cube. In the lattice points at this point is 1 2 4, right? Because right, in BCC center there is a 1, so 1 plus all the outer divided to 8, 8 into 1 by 1 plus 1 2, like that only for FCC also. And the nearest neighbor, number of nearest neighbor 6 8 12. For remembering I don't know, for example, if you can see it is 8, and the B of BCC is something in the shape of B8, right? So like if you confuse, you can remember like that always. All right. And the nearest neighbor distance, go back to the black color. Okay, now green color. Nearest neighbor distance, the nearest neighbor distance will be a root 3a by 2 root 3a by 2. Just remember that there is a simple cube, is always a, because right, and the BCC it is root 3a by 2 and FCC is root 2a by 2. As a by 2 is there and root 3 root 2 like that is going to reduce. Okay, and the number of second, sometimes they ask us the number of second nearest neighbors. You can easily calculate it, just look about it. If you like to remember, these things are easy. 12 6 6, right? Okay, and we have atomic packing fraction, APF. So APF is basically, right, APF is like a effective number of things into volume of each atom divided by volume of unit cell. This was asked in GATE 2007. Okay. So APF for a simple cube is 0.52, and for BCC it is 0.68, and it is 0.77, 0.72. We want to remember, see, also again this 8 is in the shape of B, so 0.68 and 0.7. I mean, you may remember this 0.52, 0.68, 0.72. Maybe confuse sometimes in the exam. You will confuse BCC and FCC. What was it? So BCC is around 8 and 8. I mean 8 and B are similar, so it is correspond to BCC. And there is something called hexagonal close packed HCP. For that, atomic fraction is 0.74. And for we have diamond also. For diamond shape, it is 0.34. Okay. If you are don't know about what is simple cube, what is BCC, or what is FCC, please look into the lectures or just read about it in Wikipedia and all. It will be helpful for you. Okay. Then let's move. Let's discuss now. So there sometimes they ask from this part. In JAM also I have seen this kind of questions. So these are the basic things one should definitely know. Okay. So now we have angle. For example, sometimes they ask the angle between crystal directions. Okay. Then the cos phi angle is, for example, it's a cubic shape. It is h1 h2 plus k1 k2 plus l1 l2 divided by root of h1 square of h1 square plus k1 square plus l1 square into root of h2 square plus k2 square plus l2 square. Yeah, this is for what shape? Cubic. What is this HKL? If you say the direction is HKL and this like 110 or 011, something like that, then we can just write, for example, if you say the direction is 111, it is this correspond to HKL. Okay. If they give two directions, then find the angle between this equation for cubic shape. And what if, and sometimes they ask the orthorhombic. For orthorhombic, this is a little bit different. We have a square h1 h2, just a little bit modification. If you just look into it, you will get it done. B square k1 k2 plus c square l1 l2 divided by root of a square h1 square plus b square K1 square plus C square, Lec-1 square. Maybe I'm taking a lot of time to write. Maybe you can just skip this and get the final equation. Okay, if that's the case. I don't want to edit it later, so I will just add it like that. And if you can just speed up the videos, you will get it. Okay. We have C square L2 square, right? Should be a little bit neat. Okay. Yeah, this is for orthorhombic. Which one? Orthorhombic. Okay. So if they give the direction and ask, it can be done. And in the just remember that in crystal structure that 5-4 and 7-4 rotation is not allowed. Sometimes they ask. It's a basic things. If you don't know what is ABC, alpha, beta, gamma, and all, this is a structure like for example, it is this direction A, B, C, and A and C is beta, between B and C is alpha, and this is gamma. Right? This is a usual notation. It may depend, vary. Okay, that's also there. And usual thing, distance between planes. Distance between planes is given by root of h square by a square, s square, not it's gone. Here, plus k square by b square plus l square by c square. You may know this equation, right? But here, if a, b, c are same, this will go up and a by root of h square plus that one. Okay. If you, it is asked a lot of times. For specifically in GATE 2012, 2015, and all of these equations are asked. Okay, it's important. And for example, and another thing is like in symbol cube. In symbol cube, just remember, maybe sometime they will ask this d100, d110, d. You can calculate it, but still, ratio is a by root 2 is to a by root 3, like that. Correct? It is is to, right? Okay. Okay, in FCC also there is, and we know Bragg's law, right? Bragg's law equal to. So all these videos I am randomly writing all the equations. So this is a revision. I don't want to go it in flow. So I will just write whatever the importance are asked in the previous question paper, so that it will be helpful for you. Okay? And another thing is we have discussed about the HCP structure, right? We told that the time fraction for HCP is 0.74. So in HCP there is something called as C by A ratio. So its 3 by S ratio is root 8 by 3. You don't remember it. You may don't believe it. You also asked in GATE 04. Okay. So let's move to structures. We'll pick the most important ones and most important points. Okay. For example, Cesium chloride structure. Cesium chloride structure. What is the Cesium chloride structure? It is symbol cube. How will you remember? Symbol cube as Cesium chloride is. Okay. Symbol cube structure. And its coordination number is, so since it is symbol cube structure, it is a coordination number I'll just put a CN coordination number, it is 8, and the second nearest neighbor SNN, it is 6. Okay, next one is graphene. Graphene is actually a honeycomb structure. You may have seen the structure, right? If not, just Google it, you get the structure. And its APF atomic fraction is around 0.60. Number of nearest neighbor is 3. Second nearest neighbor is 6. Its area of unit cell. Its area of unit cell is 3 root 3 s square by 2. I think those are not important, but still it may ask. Okay. Sometimes they ask in NaCl. So what will happen in NaCl? NaCl is also known as a rock salt structure. It has an FCC, but NaCl is an FCC. We have C here. We have C here. We may ask if there is also a C in BCC, but I'm just kidding. Okay. So NS is an FCC structure, you remember, and the diamond cubic is also, for example, diamond cubic structure is also an FCC actually, but it's a twofold, two atom based FCC. It's also an FCC, but two atom based. Okay, and also it have an inversion symmetry, that's important, and its atomic radius r equal to root 3 a by 8. I mean, this atom radius and all, you can just draw it and you can just use the Pythagoras theorem, you'll get it. So you don't need to remember all these things, okay? And its volume fraction is 0.34. Yeah, I think for the carbon, silicon, germanium all fall in this under diamond structure. Okay, now we have HCP structure. HCP is not a Brevis lattice. Sometimes in JAM, sometimes they ask. I remember when I was writing JAM, I think they asked this question. It's not a Brevis lattice, and its C by A ratio, as I already told you before, it is a root 8 by 3 or 1.633. So it was asked in JAM once. And its fraction of volume occupied is 0.74, and this coordination number is 12, and effective number of atoms is 6. I think that will be enough for the basic crystal structure revision. That part will be enough, I guess. And I am sure you already know about Miller indices, right? HSUK, LS, A by OA, that one. I think that won't be important. Let me just check if I miss anything. Field, simple cube, and do a lot of problems. Okay, it's always important to do a lot of problems. And there are a lot of questions asked before in this area, like this BCC, FCC, all that, and all those things. Interatomic distance, all the gate. Gate usually one question will be coming usually from these areas. They'll put at least one question here and there. In just also they usually ask. Okay, I think that will be enough. Do a lot of problems. Okay. If you have a doubt, let me know in comments. I will try to solve it for you. I think that's it. We can wind up today's session. Okay. Stop recording.